Hello students, welcome to Boundless Maths, where we make maths not just understandable but also enjoyable. In today's video, we are going to cover the topic trigonometry from class 10 maths. So as you can see, trigonometry is made up of three words: tri, gon and metry. Tri means three, gon means sides and metry means measure. So trigonometry is the study of relationship between the three sides and angles of a triangle. Earlier known works on trigonometry, they were found in Egypt and Babylon, and the astronomers, they used trigonometrical concepts to find the distance of planets and stars from Earth. Even today, trigonometry is widely used in various fields of engineering and physical sciences. So without much delay, let's get started and let's understand what are the basic concepts of trigonometry. To start with, the first thing is trigonometric ratios. What is a ratio? You must have done in lower grades also. A ratio is comparison of two quantities by division. So how do we start? For example, you have a right angle triangle and you are given the sides of this right angle triangle. The hypotenuse is 5 centimeters, the perpendicular is 4 centimeter and the base is 3 centimeter. Now if I ask you to find the ratio of any two sides of this triangle, can you find that out? Yes. So if I ask you what is the ratio of perpendicular to hypotenuse? Where is the perpendicular? 4. Hypotenuse is 5. So it is 4 by 5. If you need to find the ratio of base to hypotenuse, it is going to be 3 by 5. So that means if you know all the three sides of the triangle, you can find any ratios using any of the two sides, right? But what if one of the sides is missing? Yes, definitely you can use Pythagoras theorem. So here be careful that the side opposite to this 90-degree angle is called hypotenuse and the other two sides are base and perpendicular. As per the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So you can use this relationship and find the missing side if you are given only two sides, right? Now, why are we talking of ratios? Because trigonometry is based on ratios of these sides of the triangle and they have been given certain names. For example, sine theta. The complete name is SINE, sine, but we call it as sine theta. In short, SIN, sine theta. Sine theta is perpendicular upon hypotenuse. Cosine theta, this is cosine. Cosine theta is base upon hypotenuse. And the third one is tangent. So tangent is, tan theta is perpendicular upon base. Next is cosecant. So it is cosecant, the complete name is cosecant and we call it as cosec theta. The way you have nicknames, these angles, these ratios also have their nicknames. So it is cosec theta is h upon p, hypotenuse upon perpendicular. This is secant. Secant is known as sec. Sec theta is hypotenuse upon base and this is cotangent. So you are clear with the basic words? Cotangent is known as cot theta, which is base upon perpendicular. So the six basic trigonometric ratios are sine theta, cos theta, tan theta, cosec theta, sec theta and cot theta. So if you know all the sides of a triangle, you can find any of these ratios, right? Now let's look at what is the significance of this theta and what are we saying theta. What is this theta? Theta can be any of the acute angles of this right angle triangle. Even though in higher grades you will come across trigonometric ratios of higher angles also, but for now we are dealing with only acute angles of a right angle triangle. So the side opposite to the 90-degree angle is hypotenuse. The side opposite to theta is the perpendicular. Because if you look at this triangle from this side, theta is here and the side opposite to theta is called perpendicular. The side just adjacent to theta is base. So whenever you are finding any of these trigonometric ratios, you have to be very careful. Where is theta? Where is the perpendicular? Where is the base? In the above triangle, if you see theta was here, the theta is here. So the side opposite to theta is always the perpendicular and the side adjacent to theta is the base. And in the next triangle, theta is here. So if I name this triangle as ABC, sine of A, I can also write it as sine of A rather than using the word theta all the time. I can say it as sine A. Sine A is perpendicular upon hypotenuse. That means perpendicular for this angle is this. So if I take the lengths as 3 centimeter here, 4 here and 5 here, what is sine A? Sine A is perpendicular upon hypotenuse, that is 3 by 5. Right? Now if I ask you what is sine of C, where is C? C is here. So for this angle the perpendicular is here now. So the perpendicular is 4 centimeters and sine C is going to be 4 by 5. Now what is cos A? Cos is, what is cos? Cos is the ratio of base with the hypotenuse. For this angle A, the base is here 4, 4 by 5. Cos A is 4 by 5. And what is cos C? The base is here for this angle. So the cos C is going to be 3 by 5. I hope it's clear. Now what if I divide this sine A by cos A? If I divide them, sine A by cos A is going to be equal to 3 by 5 divided by 4 by 5. Please do these divisions carefully. Many students make mistakes here. If you are not comfortable, write it like this. And then flip the fraction after the division sign and then calculate. So the answer is 3 by 4. So that means sine A by cos A is 3 by 4. And if I want to find the value of tan A, what is tan A? Tangent. Tan A is P upon B. Where is P? Where is A? A is here. So the perpendicular is 3 and the base is 4. So tan A is 3 by 4. What do we understand by this? Sine A by cos A is giving you the same value as tan A, which is 3 by 4. So that means sine A by cos A is equal to tan A. Sine A by cos A is equal to tan A. Now you must be wondering how to remember which one is P upon H, which one is B upon H, which one is P upon B, and so on. So it's very easy. Just look at few more examples. And before we move further, let's do a small exercise. Take a little pause, breathe, and then proceed. Proceed with what? Try to balance yourself. A tree pose. Try to balance yourself. These helping hands, they are going to balance. Yes? So what are the keywords that I used? Pause, breathe, proceed. Helping hands, balance. This is going to help you to learn how to remember these trigonometric ratios. Pause, breathe, proceed. Helpful hands, balance. Sin theta is P upon H. Cos theta is B upon H. Tan theta is P upon B. Cosec theta is H upon P, inverse of sin theta. Sec theta is H upon B, inverse of cos theta. And cot theta is B upon P, inverse of tan theta. Easy? Can you just repeat with me? Pause, breathe, proceed, helpful hands, balance. Sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. Easy to learn now? Yes? Great. So what we have learnt is sin theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse, tan theta is P upon B. Now I hope you are able to relate it and learn it. Cosec theta is H upon P, sec theta is H upon B, and cot theta is B upon P. These are the basic ratios. We have seen how they are related to the sides of a triangle and how they are related to each other also, because cosec and sine are opposite of each other. Sec and cos are opposite of each other. Tan and cot are inverse of each other. Also tan is equal to sine theta upon cos theta. We have seen this, the relation between tan theta and sine theta and cos theta. So tan theta is sine theta by cos theta and cot theta is inverse of tan theta. So it is equal to cos theta by sine theta. Now a very common mistake is, please do not write sine is equal to 3 by 4. Whichever ratio you are referring to, the name of the ratio without the angle is just meaningless. So please don't write like this. This is wrong. So it has to be sine theta equals 3 by 4, or maybe if you want to use the name of the angle, sine of A is 3 by 4. Please never use any of the trigonometric ratios without this theta or without the name of the angle. This is totally wrong, because it is the ratio of the two sides of the triangle with respect to this angle being taken into consideration, right? Now let's look at few examples related to this concept. The first question is, if tan theta is 3, then evaluate this expression. Now you are given tan theta. Think how to solve this question. If you can make out something, pause this video and attempt the question on your own. If you need help, I am here to help you. So what is given to you is 4 tan theta equals 3. That means tan theta equals 3 by 4. Now in a right angle triangle, if you are given the value of tan theta means, tan theta is perpendicular upon base. So if this is theta, this is 3k and this is 4k. Why I have written k here? Because these are ratios, not the actual lengths. If you know the two sides, can you find the third side of this triangle now using Pythagoras theorem? So this hypotenuse AC is going to be equal to 3k square plus 4k square, and that makes it 9k square plus 16k square, which is 25k square. So that means the length of this hypotenuse comes out to be square root of 25k square, which is 5k. Now you know all the three sides of this triangle, so you can find any of these ratios. What is sine theta now? What is the value of sine theta? Sine theta is P upon H. So where is P? With respect to theta, P is here and hypotenuse is here. So it is going to be 3k upon 5k, and that comes out to be 3 by 5. What is cos theta? We need cos theta also. What is cos theta? Base upon hypotenuse. So it is going to be 4k upon 5k, and that is 4 by 5. And now you need to evaluate the expression given to you. So as per the expression, if you put in these values, it is going to be 4 into, what is sine theta? 3 by 5. 4 into 3 by 5 minus 3 into 4 by 5. Whole divided by 4 into 3 by 5 plus 3 into 4 by 5. Now a very common mistake here, please do not cancel 3 by 5 by 3 by 5. 4 by 5 in the numerator with 4 by 5 in the denominator. Because in the numerator two quantities are being subtracted and in the denominator they are being added. You cannot cancel it like this. You need to first evaluate the numerator, evaluate the denominator, and only then you can do the cancellation. So let's do that. 4 3s is 12. So that means this comes out to be 12 by 5 minus 12 by 5 upon 12 by 5 plus 12 by 5. Now the numerator becomes 0 irrespective of the denominator. The answer is 0. Clear? I hope you were able to do the question. Let's look at another question. In triangle PQR, right angled at Q. So let's first draw a right angled triangle. This is triangle PQR, right angled at Q. PQ is 7 centimeters. PR minus QR is 1. So there is a relation given to you between the hypotenuse and the base. So if you assume QR is x centimeters, the hypotenuse is going to be 1 plus x or x plus 1. You can write either ways, right? Now determine the value of sine R and cos R. So this is the angle under consideration. You need to focus on angle R. So now in triangle PQR, as per Pythagoras theorem, we have PR square equals PQ square plus QR square. What is PR? PR is 1 plus x. 1 plus x whole square equals PQ is 7. 7 square plus x square. A plus B whole square is A square plus B square plus 2AB, and 49 plus x square is there on the right side. X square gets cancelled. So we have 2x equals 49 minus 1, which is 48. That means the value of x is 48 by 2, which is 24. Now we know that the base of this triangle is 24 centimeter. So the hypotenuse is 25 centimeter. All the three sides are there now. So you need to find sine r and cos r. Sine r means, sine r is p upon h. So this is, look at r, where is perpendicular opposite to r, which is 7. 7 upon 25. And what is cos r? Cos r is b upon h. With respect to r, where is the base? 24. So it is 24 by 25. Was that easy? Wonderful. So we have seen how the trigonometric ratios are related to each other. In this question, if you want to find tan r, you can do that also. If you want to find cot r, cosec r, any of the ratio using this angle r, you can find any of them once you know all the three sides of the triangle, and that you can easily do using Pythagoras theorem. So we understand the basic concepts of trigonometric ratios and how they are related to each other. If you want to continue in this journey of learning trigonometry, continue watching the next part of this video, where we will cover the trigonometric ratios of certain specific angles and thereafter trigonometric identities. So these two topics will be covered in our next video. So till then, keep learning, keep growing and keep practicing, because mathematics is all about practice. Understand the concept, practice as many questions as you can. If you have any doubts, if you have any questions, please write them in the comments below. And if you want me to take up any specific topic from class 10 maths, you can write that too in the comments below. I'll share the video for the same, right? So stay tuned, keep thinking, keep growing and keep learning. Thank you.